Hello, I think we should be live right now. So let's move here. So welcome to my presentation today. And we will be talking about Azure App Service and SSL certificates on it. And before we move there, let's talk a little bit about what this actually is. So these are the Finland Azure User Group Tips and Tricks Sessions, and these are kind of 30-minute coffee break like sessions for the whole community, by the community. And Finland Azure User Group is of course the largest, I think, current community, at least Azure community in Finland. And like shown here, we have over 1,600 members right now. And we organize over 10 events yearly, and IgluConf is the largest one right now. And these sessions you can always view later on the Finland Azure User Group YouTube channel that you are watching right at this very moment. Let's get to the actual presentation. So, I'm Pasi Huuhka. I'm an Azure MVP, and I work as a DevOps architect at Azure. And I've been working on Azure since 2014, roughly. But let's be real here, most of the stuff that we were doing back then were very basic. But since then, I've helped to automate and develop applications for at least 30 customers, even more probably, from startups to enterprises. I write a blog at huuhka.net roughly every week, sometimes a bit less. And I'm also one of the organizers of Finland Azure User Group. And I have gained some certificates in the past years, and we are also organizing this global DevOps bootcamp later on this year. If you're interested in that, check out the link here later on. People watching this probably know Azure, but we are a smallish consultancy company who do primarily Azure PaaS and Azure serverless stuff. And basically we have a lot of experts in the company with, like shown here, 14.2 years of experience on average. We also have 4 MVPs. We are Microsoft Gold partner and so on. And this year we also expanded to Belgium. So we are working in 2 countries right now. So then about the session itself. So we'll take a short look at what options are there for SSL certificates in Azure App Service. Then I will show you a demo of 3 different ways in an automated fashion, and you will also get the ARM templates and scripts and whatever is required to get this working for yourself. Then we'll talk a little bit about what of these should you use and when. There are kind of a lot of ways of doing this, and they have some pros and cons to all of them. And if at any point of this session you have any questions, please write them in the YouTube chat and I will take a look at them at the end of the session. And it seems that the stream is running correctly, so let's begin. So first of all, let's take a little look at the options, what there are. So first of all, we have a manual way of adding your own certificates. These are always key vault based, and key vault basically has the capability to create either self-signed or self-imported certificates. And on top of this, there's also the capability to add your account for DigiCert or global sign to your key vault. And this kind of allows you to also provision kind of real certificates from those CAs. These certificates can be located in any subscription within the same tenant, of course. And the setup that I'll be showing here differs if the application is in a different subscription than the app or the certificate itself. And for most of this, you kind of have to handle the renewal process of the certificate yourself, which is why they are called kind of the manual way. But of course, if you use the Key Vault created certificates, you can automate the refreshment there too. Then we have the managed certificates. So they are either based on Key Vault or the Microsoft.web/certificates resource provider, which kind of means that they are an Azure resource in your resource group, though those resources are often hidden in the resource group. For these, there is no self-importing, and all of the certificates are valid, so there is no way to create a self-signed managed certificate in this perspective, at least. These certificates are officially only supported from the same subscription in most cases, but there might be a way that you could hack your way around this, but I would not suggest doing that necessarily. And the good thing here is that certification renewal is always automated. And that's kind of really what you want to be doing, right? I don't want to be renewing my certificates manually if I have another way of doing it automatically, of course. Then on the types of managed certificates, and two of these we'll be taking a look at today. So first of all, we have the app service certificate. And this is when you buy a certificate for a year from Microsoft themselves, from the Azure portal. And this is stored as a Microsoft.web/certificates resource, but it needs to be imported to a Key Vault on the back end. And this means that the app service really needs the same permissions set up as in the manual importing way. Then we have the Let's Encrypt extension. So this is managed by a third-party extension. It is not officially supported, but it has been battle tested by many, and I have been using this myself for my blog for the last year or so. And I think the extension has been available for like 5 years now. Some companies might not like Let's Encrypt, and that's mainly because anybody can get the certificate. You don't need to be kind of an official entity to get one. Anybody can just request one as long as they own the domain. But I don't see that really as a downside in this case, because the next part, app service managed certificates, are kind of also free and anybody can get them. So they are managed, they are free, there's no hassle with them. So, and obviously those are the ones that you should be using, at least in the future. But these are still in preview, which means that your mileage may vary. For this reason, I'm not going to do any demo deployment of the managed certificate right now, but I will still show you how it works, because last week when I tried this out myself, I couldn't get a certificate deployed at all, but this week it worked, so who knows if it works right in this demo. And the other downside for these is that currently no naked domains or Apex domains are supported, but they are on the roadmap, but there's still no ETA for them. What this means is that you cannot provision a plain huuhka.net address, for example. You would need to do something like www.huuhka.net. But let's get to the demos themselves. So before any of this setup, I have done the CNAME stuff as shown in the image right now. So I just have from my own domain pointed these CNAMEs to those web apps. And this is required because whenever you add a custom host name to an Azure App Service or Azure function, they need to be done with a CNAME or TXT entry in your DNS server. So you can basically say that I own this domain. So let's begin then. The first thing that I'm going to show you is the manual import or creation of your own certificate. I have 2 key vaults here. One of them is in East US, one of them is in West Europe. You only need one, but I'm going to use this one to show that basically the certificate can also be in a different location from your app service itself. My app service will be in West Europe for this. So to take a look at the one that I'm currently not using, to go through a little bit on the permissions that are required. So first of all, the certificates. I have here my own self-signed certificate that I have generated through this button here. And here we can specify either generate or import, give a name, and then the type. So I've created a self-signed certificate, but you can do an integrated CA or non-integrated CA. I've actually never tried the non-integrated CA myself, but with the integrated ones, as you can see, we need to set up a certificate authority. And we would need for DigiCert account ID, account password, and organization ID. I don't have any of these accounts, so I can't really use this myself. So in the end, if you're using this, you still need to have some kind of account for those CAs themselves. But then the permissions. So how does the app service actually get this certificate from the key vault? Well, first of all, it is not using any service principal or any kind of managed identity that you would think that it would use. But no, in the back end, what it is using is the resource provider identity. And that is this Microsoft Azure App Service application. And this is found in every Azure AD tenant with the same application ID and the same name. But the object ID might differ, I think. And for government Azure ADs, the application ID is also different than for public. But the permissions that are needed are actually secret permissions and only get here. You don't need anything else. And it's kind of confusing, and I don't know the direct reasoning for this, but as the certificate is a certificate resource, you still don't need any permissions to the certificates here to get the cert out. I think what happens in the back end is that Key Vault actually changes the certificate to a secret value, and it's really a secret kind of resource on the back end. So that's why you need to have permissions to secrets themselves. And on top of this, depending on how you are doing your deployments of your ARM templates, for example, you need to do a little bit more. So in the access control part here, we need to have some role assignments. So first of all, what you need to do is for your service principal, in this case, I'm just using a service principal that I created. So in the demo, you can think that this service principal would be the one deploying my ARM templates. I have created a custom role for this. And this is because I want to, of course, have the least amount of privileges to the Key Vault. Let's say that my company is hosting a wildcard certificate in this Key Vault. We don't want to give anything more to the actual service principal than necessary. But the only permission that we need is Microsoft Key Vault, the Key Vault resource, and this other actions use Vault for Azure deployments. So You can see here it's microsoft.keyvault/vaults/deploy/action. And this is actually quite new. I think this came in last month or 2 months ago, something like that. Earlier you needed this right here, and that was kind of dangerous in my opinion, because if you have write permissions to your key vault, then you can modify the access control of the key vault itself, or the access policies, kind of the data plane access, which would mean that you in effect own the key vault through that service principal. But this way we can just limit it for just deployment. And one thing to note here is that in the access policies, the advanced access policy Azure Resource Manager for deployment, this is not needed either for this, even though I'm deploying an ARM template, which is using this key vault for deployment. This is for kind of getting other values during the deployment, but our thing is kind of happening on the back end a bit differently. And then the other permission that we are needing here is this. So the same service principal, so the resource provider identity really here needs reader permissions to the key vault. And this is the part that is different depending on if the key vault is in the same subscription as your app service. If it's in the same one, you don't need this reader at all. But if it is in a different subscription, this will need to be added for this to work. Then let's actually get to deploying something. So first of all, I have created a script to do this whole configuration for the key vault permissions, and this can be found in the GitHub link in the description. But basically, I'll set this to run. I would if my copy would work. But again. So basically what this does is that it checks if we are on a government subscription, if you give it the switch. Then we specify the app service RP SP ID, as it differs kind of if you're in government or not. We switch to the subscription of the key vault. Then we get the key vault information, so really just the resource ID. And then we get the custom role definition ID. We could use key vault contributor, which has that permission, but as I mentioned, you don't want to give right to this permissions or right to this SP that is deploying this. So I wouldn't suggest doing this. And then we just give the custom role definition ID to our service principal that is deploying the ARM templates. And then we give the resource provider identity, the reader permissions. And lastly, we just give the access policy here as well. And as we can see, we gave the certificate deployer and the reader permissions in this case. Let's change back to my application subscription and take a look at the ARM template that we will be deploying. So in this case, we are just deploying a function app, just to show that this works with functions just as well as app services. So we just have a UI function proxy, which doesn't really have anything inside it. We could have a storage account, so we could host our static website there, and so on. So the important things here is that we are taking in a custom domain, the resource ID for our key vault, and then what is the name of the secret inside there. And the important parts here are that, well, first of all, we have the server farms, so just a consumption plan. Then here's the certificate part. So we have a web./certificates resource. We give it a name of the custom domain. This can be whatever, I think. It doesn't matter in this case. And then we specify in the properties the key vault ID that we are taking in, and then the secret name. Well, once the permissions are ready there, this is all that is really needed. And while we don't specify the server farm ID here, we still need to depend on the server farm. Yeah. Because you can't import it while the creation of this is in progress. So let me start the deployment here while we go through the rest. So then here we have the website itself. So basically we have a function app, and the important part here is the hostname binding. So basically what this does is sets the custom domain as a hostname to the application. As I have done the CNAME stuff already, this works just fine. And this part basically sets up the SSL. So we have an SNI enabled SSL, and then we just get the thumbprint value of the web/certificates object and use it here. Pretty simple like that. Let's see what's happening on the back end on our resource group. So our app service plan has been deployed already. If we show hidden types, we can see that the import of the certificate has been done. It's in West Europe, and as we can see here, let's see what this actually is. Yeah, well, we actually can't see it here, but basically this is using the East US key vault that we just gave the permissions to. And now that we have our function app and go in here, we can actually see that the URL has changed to what we actually want it to be. And there's really nothing inside this app service right now, or this function app. And as we are using a self-signed certificate, this of course doesn't really work in this case, but we can see that if we take a look at the certificate, what's there, well, it is the self-signed certificate that has been configured here. And from the app services point of view, everything should be working. And if we take a look at the configs here, we have our custom domain set up, and we have a binding with the private certificate thumbprint, and we have the private certificate uploaded here. Quite simple that way. The next part that I want to show you is the Let's Encrypt extension. Even though it's not officially supported, I would still think about using it. So while I'm gonna deploy this, we'll go through the ARM template that I have, and I'll show you how the configuration works on that. Let's actually start with here in the deployed app service. So the extension is just here in this menu. It's called the Azure Let's Encrypt in this case, and it's actually found in GitHub as open source if you want to take a look at it. I think I linked it in the description too, but it's by this Simon Peterson guy. And as we can see, there are pull requests and issues open, and it's under active development still. So let's go to the ARM template then and see how this differs from the earlier one. So let's create an ARM template which does both of the managed SSL stuff for you. So we can have a Let's Encrypt or just the app service managed certificate through this ARM template. And we don't really give in anything important here, just some web app SKU stuff. Then the Let's Encrypt config, so this is something that you need to give in. So the tenant, the client ID, so this requires a service principal on the back end, and you need to kind of configure the secret for it yourself. And this is required to kind of set up the certificate on the app service. as we can see soon, this ARM template doesn't really configure the same stuff as we configured earlier, because the service principal during the setup will do that part. So in the end, this service principal then requires contributor permissions on the resource group itself. But I will be giving real information in. This is just an example. Then we take in the customer domain, location, and then just some environment information. This is only needed for the Let's Encrypt part, and it defines whether to use the staging or production Let's Encrypt domain. So if you're using the production, it only allows you to get 5 certificates per domain weekly. So if you're just doing some testing, you might just use the staging one. So we have a normal server farm here, so we give it the SKU. Then we have a normal application. There's nothing really important here other than the custom domain that we configured earlier as well. This is required for both the managed ones. But as we can see, there are no properties. We just need to have the host name kind of registered to the app itself. Then we have a storage account for just the web app logs and the dashboards. And then we have a site encryption installation. So this installs the Let's Encrypt extension. You don't need to configure it here in any way. But what it does require is connection strings, the Azure Web Job storage, and the dashboard information. Usually I've added these as the normal app settings configs, but Let's Encrypt requires these as connection strings. I don't know if it really matters to the app service itself at all. Then we have the required app settings that actually configure the Let's Encrypt extension. So they need to have the, let's actually show what this is. It's colon maybe. So basically Let's Encrypt colon tenant, subscription ID, client secret, where is the application, where is the service plan for that application, so the app service plan, whether they use IP-based SSL or not, then the Let's Encrypt URL, so production and staging, and the email, and what your host names are that you want to register. This is not totally automated. I found an issue on this that you still need to go to the portal and do some configurations before this actually works. So while this config is correct, it's just not getting the actual certificate for you. But that is quite quick to do, and I think you could probably even write a script to do that if you wanted to. But to get to the extension, you would go here and then click Browse, Loads, and that leads you to this kind of view. And this kind of shows you some information on what the required app settings are. And one thing to note is that I haven't tested this, but I think that as this is the colon that's needed, this probably doesn't work on a Linux app service. But your mileage may vary. But as we can see, it says that automated installation should require these service or app settings that I have. And these are fetched from the app settings, but I've deleted these because I don't want to show them in the stream. And then you would go click next here just, and you would get here. These two app services that I have are on the same app service plan, so it's showing my managed certificate here, but don't mind that. But we can see that we have the host name set up. Let's zoom in a little bit. And then we can see that there is no SSL binding on it. And to actually configure this, we'd go click next. Let's hope my demo works. We select which host names to do this on. I'll just use my pure email here. Let's hope it works. Well, actually, my configuration probably have this email, and let's use the staging one here. And then request an install certificate. And now we wait and hope that everything works. In the meantime, while it is requesting this, shouldn't take too long, we can see in the web jobs that this is using on the back end, that basically we have done some add certificate calls, renew certificate calls, and cleanup calls. So this renew certificate web job really handles the renewal on the back end if your configuration is correct, and you will also get an email from Let's Encrypt if this is about to expire, but the app or the extension should always renew it before you get the email. If you get it, then you know something is wrong and you need to take a look. We have a certificate successfully installed, and if we go to the app here, we can see that as our ARM templates did not really configure anything other than the custom domain here, we can see that it has been actually done by the service principal in question here. So we have figured this. We have our private certificate thumbprint, and also we have the private certificate in this location. So let's go to the actual URL of this application and hope that this works. Still have a privacy error, but let's see if we can refresh this. A bigger privacy error. This doesn't look very good. Let's see what the problem is. So we have some certificate here, but I think this actually might be because I was using the staging here. It should still work. Let's take a look. Remove this and see if we can actually get a new one. So let's not use staging. See what happens. I've not tried this before, so it might work, it might not. But while this is doing this on the back end, let's move to the managed stuff, as I'm running out of time here. So the managed certificate itself is basically quite similar. So we have the custom domain certificate resource here. We need to give it a server farm ID, in this case our server farm, and the only thing we need to do actually is give a canonical name. This is the property that defines if it's a app service managed certificate or not. But we run into a chicken and egg problem here, because for the app service managed certificate, if we take a look at the managed app here, this is probably better. So the deployments here. So I try to deploy this, and we get an error message that the canonical name is invalid. So my host name requires to be added to the app. But currently, the only way that you can actually configure in ARM that I have found, other than some 2015 API, was that you configure the host name properties with the SSL state, like shown in the import part. Let's see if I have it here. So this way, so SSL state and the thumbprint of the certificate. But as we can't define the same resource twice in my ARM template, I need to cheat a little bit. And this can be done with a linked ARM template deployment. So what I do here is I just do a deployment with some name, update host name, and I have another ARM template, a little one, in my GitHub, which I have in these variables. And then I just give it a custom domain and what is the name of the web app. And if we take a look at that, we basically see that the only resource here is the host name binding, and the only things that we do is just the SSL state and the thumbprint that are updated now that we have added first the custom host name to the web app, and then we can do the configuring afterwards. And this, as we can see, depends on the certificates to be created here for the custom domain. And for this it looks very similar to the previous one. So if we take a look at the SSL settings, we again have, now we have 2 certificates here. Let's see what happens with that. But yeah, we have the managed certificate. In this case, it has been bound to the managed.age.dev, and this should also show me the ID. And now we get no errors here. And if we take a look at the certificate itself, if I can zoom this in a little bit, we can see that it's been issued by GeoTrust RSA to my hostname. These are 6-month certificates as shown here. I think the Let's Encrypt ones are, I think they are 3 months. Let's see what happens now. Yeah, so as we are not using the staging, we can see that we now have a valid certificate from Let's Encrypt on our side too. So both of those work just fine. All right, so those were my demos, and you can always find, actually I have the link on my PowerPoint, so let's go there. So you can find the sources at azure.li/pasi/arm, and I have some other ARM templates there as well if you need. But let's see if this actually works. It does. So in the app service folder here, part, we have the manual one, managed one, the host name stuff, and also the script if you want to use those. But other than that, let's take a look if you guys had any questions, if my chat actually works. Doesn't seem like right now, but if you have them, please write them in, and we can then take a look at those. Now, while you guys are asking the questions, the next session on the Azure Tips and Tricks is on next Tuesday, so the 23rd at 16 o'clock. And it will be by Eleni Santorino, and I probably just butchered his name there pretty badly, but he will be talking about Cosmos DB, if I'm correct right now. And we actually have 2 speeches coming up next week, one by Eleni and the other one by Sakari Nahi from Azure. And he will also be talking about Cosmos DB, so it's a Cosmos DB double trouble that week. So please tune in then. Let's see if I need to refresh the chat. No questions still. Do I have any other slides? No. All right. If you still have any questions, you can find me on Twitter or LinkedIn or whatever. Ask them there, and let's get back to work for today. Thanks everyone for joining.